Hey guys, I saw this post on Reddit and it says, why is 6 afraid of 7? And the answer is this right here. This is a pretty clever joke. Let me show you what's going on. Let's start with an equilateral triangle, a square, and a regular pentagon. Let's construct all the lines of symmetry and that'll make multiple congruent triangles in each of the figures. Let's pick one of them. It doesn't matter which one. Let's do these right here. This will end up being a 30-60-90 triangle. This will be a 45-45-90 triangle. And this will be a 54-36-90 right triangle. Let's set each of these hypotenuses equal to 1. Would that be hypotenae? I think it's hypotenuses. Now, if this hypotenuse is equal to 1, the side lengths are equal to √3/2 and 1/2. For this one, if this is equal to 1, it's √2/2. And for this one, if this is equal to 1, the sides are going to be this and this. These two aren't too difficult to find. This one's really fun. It uses the golden ratio. I can do a future video on that later. But for now, we got to focus on this joke. Next, let's take the sine and cosine of each of these. Sine is opposite over hypotenuse. So sine of 30 would be 1/2 over 1. And cosine is adjacent over hypotenuse. So cosine of 30 would be √3/2 over 1. Same thing for this one. Sine is this and cosine is this. And for sine of 54, it's going to be this, and cosine of 54 would be this. Take a special note that these sines are exactly the heights of the triangles, and the cosines are exactly the bases of the triangle. That'll happen in any right triangle if the hypotenuse is equal to 1. So this is cool if all you're interested in was 30s or 60s or 45s or 54s or 36s, but what if you wanted to know for different angles? These formulas will help us get numbers other than 30, 45, 60, 54, or 36. These look crazy. Can we really trust them? Let's see if we can prove them. Let's construct angle alpha. And somewhere inside of it, let's construct angle beta. At some point along here, let's construct a perpendicular line. And from this intersection, let's draw a perpendicular line to this side. And let's extend it up here. Next, from the vertex of these angles, let's draw a line parallel to this one. It'll also be perpendicular to this one. And from this point, let's draw this line parallel to this one. And this will end up being perpendicular to these two. And now let's focus on these two parallel lines and this transversal. Using these notes, since this whole thing is alpha, we know this angle will also be alpha. And then let's draw this angle. I'm not going to label it. Let's just call it the purple angle. We can see here that purple plus 90 plus alpha equals 180 degrees. Since the interior angles of a triangle always sum to 180 degrees, we know that purple plus 90 plus alpha is going to equal 180 degrees. And now we have a nice looking rectangle. Let's trim off all of this stuff. This angle down here is going to be equal to alpha minus beta. Let's focus on this triangle right here. We don't have any labels yet, so let's call this hypotenuse 1. Since the hypotenuse is equal to 1, we know this side opposite of the alpha minus beta will be the sine of alpha minus beta. And this side adjacent to the alpha minus beta will be the cosine of alpha minus beta. And sine alpha minus beta and cosine alpha minus beta, that's these two things right here. So let's see if we can figure out what these are equal to. And now let's focus on this triangle. Since this hypotenuse is equal to 1, this side opposite the beta will be the sine of beta, and this side adjacent to the beta will be the cosine of beta. Next, we can focus on this triangle here. This hypotenuse is not equal to 1, so we can't do our little shortcut. Let's call this side opposite the alpha A. And we know that the sine of alpha will be equal to the opposite over the hypotenuse. So we can say sine of alpha is equal to A over cosine beta. Now, if we want to solve for A, we can multiply both sides of the equation by cosine beta. On the left-hand side, it'll just be sine alpha cosine beta. And on the right-hand side, these cosine betas are going to cancel each other out. So now we have our value for A. A is equal to sine alpha cosine beta. And we can do the same thing for this up here. Let's call it B. And we'll say cosine of alpha is equal to adjacent over hypotenuse, which will be B over cosine beta. Next, we can multiply both sides by cosine beta, and that gives us cosine alpha cosine beta is equal to B. So we can update this up here. And now we can notice another little pattern. In any triangle where the hypotenuse is not equal to 1, the side opposite the angle will be sine of that angle times whatever the hypotenuse is. And same thing for the adjacent side. It'll be equal to the cosine of that angle times whatever the hypotenuse is. So let's do the same thing over here for this triangle. For this side opposite the alpha, it's going to be sine alpha times the hypotenuse sine beta. And this side will be cosine of alpha times the hypotenuse sine beta. And now that we've figured out everything in the rectangle, we can set the opposite sides congruent. First, let's set this right-hand side equal to the left-hand side. It'll be cosine alpha sine beta plus sine alpha minus beta equals sine alpha cosine beta. And we're trying to solve for this sine alpha minus beta, so let's subtract this other thing from both sides. On the left-hand side, these are going to cancel each other out, and on the right-hand side, we end up with all of this. And this is exactly this first one right here. That was pretty cool. We just verified the first equation. Next, we can set this bottom equal to the top. It's going to be cosine alpha minus beta equals this plus this. And that is exactly this equation here. So we have now verified these top two. Now let's see these formulas in action. Let's use the 45 and the 30. Let's let alpha equal 45 and beta equal 30. So it'll be sine of 45 minus 30 equals sine of 45 cosine 30 minus cosine 45 sine 30. And same thing down here, we can do cosine of 45 minus 30 equals all this. Well, 45 minus 30 is equal to 15, so we're going to end up finding the sine of 15 and the cosine of 15. Sine of 45 is equal to root 2 over 2. Cosine of 30 is equal to root 3 over 2 minus cosine of 45 is root 2 over 2, and sine of 30 is 1/2. And we can do the same thing for this formula. Cosine of 45 was root 2 over 2. Cosine of 30 was root 3 over 2. Sine of 45 was root 2 over 2, and sine of 30 is equal to 1/2. Now let's clean this up a little bit. Root 2 times root 3 is root 6, and 2 times 2 is equal to 4. And for this one, root 2 times 1 is equal to root 2, and 2 times 2 is equal to 4. So we just found out that sine of 15 is equal to root 6 over 4 minus root 2 over 4. And we can do the same thing for cosine of 15. Root 2 times root 3 is root 6, 2 times 2 is equal to 4. And then root 2 times 1 is equal to root 2, and 2 times 2 is equal to 4. So we have cosine of 15 degrees is equal to root 6 over 4 plus root 2 over 4. Pretty cool, huh? Let's add these to our collection of sines and cosines. Now let's draw another rectangle a little bit different where angle alpha is here, angle beta is here, and the right angle's down here. Let's call this hypotenuse 1, which means this side opposite this beta will be equal to sine beta, and this side adjacent to the beta will be equal to cosine beta. And then if we look at this triangle down here, the side opposite the alpha is going to be sine alpha times the hypotenuse cosine beta. And the adjacent side of this triangle is going to be cosine alpha times the hypotenuse cosine beta. And then for a second, we can call this angle C. So we know that C plus 90 plus alpha equals 180 degrees. Well, that means that C plus 90 plus alpha will also equal 180 degrees. So we know that this angle is equal to alpha. And now if we focus on this triangle, the side opposite the alpha is going to be sine alpha times the hypotenuse sine beta. And the side adjacent to this angle alpha is going to be cosine alpha times the hypotenuse sine beta. And last, we can do this triangle. We know that this angle and this angle are alternate interior angles. Since the top and the bottom are parallel, this is going to be equal to alpha plus beta. And I made it purple because I'm mixing the red and the blue. In this triangle, the side opposite the alpha plus beta is going to be sine alpha plus beta times the hypotenuse, but the hypotenuse is equal to 1. And then the side adjacent to the alpha plus beta is going to be cosine alpha plus beta times the hypotenuse, which is equal to 1. And now we have our sine alpha plus beta and our cosine alpha plus beta. Let's set these sides congruent and figure out what these equations are going to be. First, let's do the left side and the right side. It'll be sine alpha plus beta is equal to cosine alpha sine beta plus sine alpha cosine beta. And that is literally this equation right here. And then we can do the top equal to the bottom. It'll be cosine alpha plus beta plus sine alpha sine beta is equal to cosine alpha cosine beta. Now we want to get this all by itself, so let's subtract this from both sides. And that gives us cosine alpha plus beta is equal to all of this. And that'll match this one exactly. So we just verified these last two equations. We should play around with at least one of them. Let's do this one on bottom. We've already played around with the 45 and the 30. Let's do the 54 and the 15. So we'll let alpha equal 15 and beta equal 54. And we'll do the same thing for this side. The alphas will be 15 and the betas will be 54. In the place of the cosine 15, we will plug in all of this. And for the cosine 54, we can plug in all this. And then we're going to subtract sine of 15, which is equal to this, times the sine of 54, which is equal to this root 5 plus 1 over 4. And now we have a value for cosine 69, and we can add that to our collection. So it was really fun playing with these formulas. Let me show you another way we can find more angles. We can draw this angle of 69 degrees off of our positive x-axis. Let's drop this perpendicular, which will make a right triangle. Let's make this hypotenuse 1, which will make this side this whole cosine of 69. Now there's something really cool we can do here. Instead of it being just the 69, we can go all the way around and we end up having an angle of 69 plus 360. This is going to have the exact same cosine value, and 69 plus 360 is equal to 429. So let's add that to our collection as well. Cosine of 429 is equal to all of this, which is the same as the 69. And if we want to, we can go around the circle again and add 360. It's still going to be the exact same value. Pretty cool, huh? So we just did a whole bunch of work to get this equation right here. Let's get rid of everything else and put a box around it. So that was really fun, but we should probably get back to the joke. Let's copy this whole thing down here. We have something minus something divided by 16. We can separate this into two separate fractions with the same base of 16. Next, we can break this 16 up into 4 times 4, and we can break this 16 up into 4 times 4. And we can make this 2 a root 2 times root 2. For the first one, let's rearrange things like this. We can split this into a product of two separate fractions, each with a base of 4. And we can do the same thing here. Let's split this into a product of two fractions, each with a base of 4. Next, we can distribute the square root of 2 to each of these, giving us root 6 plus root 2. And we can do the same thing here. We can do root 2 distributed to each of these. That'll give us root 6 minus root 2. Next, we can distribute this square root of 2 into both of these. Since this is already under a square root, we're basically going to multiply each of these by 2. 5 times 2 is equal to 10, and this one's going to be negative 2 root 5. Now we can put parentheses around each of these and move it up here. And you'll notice that this is the same as this is the same as this is the same as this, and this is the same as this. So this blue expression is the same as this, which is the same as this, which is the same as this. So by the transitive property, we know this is equal to cosine 429 plus 360. Let's add the 429 and the 360. 400 plus 300 is 700. 20 plus 60 is equal to 80, and 9 plus 0 is equal to 9. And now we have the answer to our question. Why is 6 afraid of 7? Cos 789. How exciting. I thought this was a brilliant joke. The instant I saw it on Reddit, I immediately knew the answer to the joke, but it took me quite a while to figure out how to explain it. I really did enjoy researching the proofs for the angle sum and angle difference properties. And if you'd like to fine-tune your trigonometry skills so that you can research your own proofs, Brilliant is a great place to get started. Brilliant has at least 2 full courses on trigonometry, one that focuses on right triangle trigonometry and one that focuses on the periodic functions. We used pieces of both of those to understand the joke. And they have tons of other content from all types of topics for students grades 5 through college. And Brilliant's new tutor Koji is the latest tool to make things even better. My favorite interactive lessons are still there, but now if a student needs guidance at any step, they can turn to Koji. Let me show you an example.
Block all messages with the meeting minutes SCR file attached.
So here's a course on functions in Python. We need to figure this out. And let's say we know that the first one is equal to this, but now we get stuck on the second one. We can ask for help. What are the difference between the two options?
Think of the in keyword, like checking if a letter is in a mailbox. Which of these acts as the mailbox that holds the files?
Okay, so we're thinking of in as is something inside. So we want to do is attachments in malware or is malware in attachments? Well, we want to know is there malware in the attachments? And then it confirms exactly.
Since attachments holds the files, the print should happen when malware is in attachments. Go ahead and hit check to run your code.
We can hit check and it runs the code for us.
You got every single one. Nice work.
I'm pretty happy that students today have access to a resource like this. Click the link below or scan the QR code to get started with Brilliant's Tutor for free. You can upgrade to Premium to unlock all courses. And right now, AndyMath viewers can save 20% off an annual premium plan. You can visit brilliant.org/AndyMath. How exciting.